Hi and welcome to MSc. In this video we're going to be looking at the binomial theorem, specifically how to find a term in the expansion. So here we've been asked to find the third term in the expansion of a plus 2b to the power of 7. Again, I've included a coefficient here just to keep things a little bit interesting and so you can see how you can deal with what could potentially be a little bit more of a challenging piece by having coefficients on the variables. In order to do this, we're not interested in the whole expansion. I'm going to look at just the general term to be able to solve this without having to write the whole thing out, because as you can tell by doing some of these problems already, that this can be kind of tedious to work all the way through and expand fully, even with the help of the binomial theorem. So here are some things we know already about this that's important to identify. It's important that we understand that the n value here that we're dealing with in our problem is 7, and that comes from the exponent here of 7. The other thing we have to identify is because we're dealing with the third term, we know we're looking for the t equals 3. That's what I'm trying to actually solve. But because the term number is r plus 1, this actually means that our r value here is 2. So let's go through and figure this out. We know that we're looking for the third term. And we know that this is going to be this n choose r. And again, here you can write this out as n choose r. So I know that this is n, which is 7, choose not 3, but 2, because r is 1 less than the term number. Then we're going to have our a value, which is actually just a in this case, a, and it's going to be to the n minus r, so 7 minus 2. Then my b value, which is 2b in this case, is going to be raised to the r value, which is just 2. So we have all the pieces we just need to evaluate now. Now this 7 choose 2 might pose a bit of a problem. If you have a calculator, you can just use your NCR button on the calculator. If you don't have that, you'll have to remember what the NCR actually means mathematically. And what it means is n factorial over r factorial times n minus r factorial. So we're going to do a little bit of factorial work here. I'm going to assume that you maybe don't have a calculator for this problem. Maybe it's an IB paper 1 question, or your teacher's looking for you to use factorials as opposed to just the calculator shortcut. So the n factorial is going to be 7 factorial, which is of course actually just 7 times 6 times 5 times 4 times 3 times 2 times 1, all over the r factorial, which is 2 factorial, and then we have 7 minus 2 factorial. So we can write this out as 7 times 6 times 5, and I'm actually going to stop there at the 5, and I'm going to make it 5 factorial. So I've rewritten that 7, and we're going to have 2 factorial, and the other bracket becomes the 5 factorial. So you can see why I stopped, because this 5 factorial is divided by that 5 factorial. So really what we have in this case now is we have 7 times 6, which is 42, divided by 2 factorial, which is 2 times 1. So this is just going to equal 21. And so that means that our first coefficient here that would come from Pascal's triangle will be 21. The a value here, which is just an a in this problem, is going to have an exponent of 5, and the b as an exponent of 2, but the 2 also sees this 2. So 2 times 2, or 2 to the power 2, is 4. B squared. And so we're almost done here. We just need to now multiply out our whole numbers. So 21 times 4 is going to give you 84, a to the 5, b squared. And now we found the third term in this expansion without having to do all the work of the entire expansion using binomial theorem. Also, we went through longhand figuring out NCR, which in this case, of course, was 7 choose 2. And we showed that with factorials. This would be made even quicker if you were able to use a calculator to just use the NCR button. I hope this short example has been helpful. If it has, please consider subscribing to the station and liking the video. And as always, thank you very much for listening and watching.